With that, we'll bring up our speaker, Austin Mejia, and he is here to talk about AI wearables. So with that, I will turn it over to Austin.
Can people hear me? Oh, there we go. Yeah, that's live now. This is crazy. I'm normally used to just being able to project and not needing a microphone, so a bit net new for me, but super excited to be chatting today. Hey, howdy folks. My name is Austin. I lead AI for our wearables group at Pixel, and I'm here to tell you a little bit about wearables and why they're going to really transform the future of our personal computing. So I think it's worth calling out that there's so much momentum happening with wearables right now, and it's happening so quickly. For example, the Meta Ray-Bans. They just had their Connect event yesterday. I won't touch on that too much, but you can see that just in quarter two in this year alone, their sales volume tripled, right? Huge amount of growth. You normally don't see that from large product players in the space. Here's another one, Humane Pin, or not the Humane Pin, the Plod Note Pin. They have 10x'd their growth every year for the past 2 years, and they've never raised venture funding. Virtually unheard of. This is like Google level growth, and they've had no backing whatsoever. Of course, we also know another company, right? This is IO. They raised $6.5 billion as an investment from OpenAI just to build their AI wearable. So clearly, there's a lot of momentum. There's a ton of hype in this space. There's also a lot of failures as well that we're well aware of, right? We have the Humane Pin, which was a huge disaster, didn't even last a year, got recalled before it could even happen, had tons of issues. You might also think of something very close to home for Google, Google Glass, right? This is often seen as the wearable failure, right? And so we should really be asking ourselves, as we see all this momentum happening, how do we disambiguate between what's real and what is clear market momentum and traction versus what's just hype and what's clearly not going to stick and last in the long term? That's what we're gonna get to today. So we're gonna take this step by step. We're going to talk about why wearable AI now, what's happening, and what are the real market forces that are helping feed into that. We're going to then talk about the opportunity, right? Where do wearables intersect into our lives, particularly in the business context, right? We're going to think a little bit about productivity in the B2B here. And then lastly, if you're a business owner yourself, we're going to talk a little bit about how wearables might be able to integrate and how you might be able to evaluate some of those solutions. If we have time, I'll get into the nerdy stuff where I talk about actually building wearable AI, but my understanding is that this is a strategy track, so we're gonna skew more towards executive strategists. You'll also note a disclaimer at the top. AI is evolving so quickly, right? Meta just had a huge announcement that changed the game just yesterday, and so really take this as a timestamp of what's happening in the ecosystem today. So a bit about myself, Austin, product manager. I lead the team here. It's a team I created, and I'm also an advisor with many universities and academic groups as well. So let's jump right into it, and I want to emphasize that this is my personal opinion as well, right? Not the view of Google's. I do work at Google, but what I'm about to say here does not necessarily reflect our roadmap, nor does it reflect my own personal beliefs as well. So with that out of the way, why wearables now? 3 big reasons here that I want to highlight. The first of which is just sheer desire and will. The second of which is hardware capabilities. And the third of which is user experience. And we'll step through each of these. Desire and will. Let's talk that first and foremost. The most important thing I want to emphasize, which can't be understated enough, is that wearables simply feel like the future. We have constantly sought to build technology that we imagine purely because it captures our imagination. And there's something about wearables that is just difficult for us to move past, and we can see time and time again in media, we keep trying to envision the world where wearables fit into our lives. To that extent, wearables are somewhat an inevitability because the human imagination is so powerful. At the same time, it's worth noting that wearables have some real form factor benefits. They're less intrusive, right? Rings, watches, glasses, necklaces. These mimic things that have existed in our society for centuries, if not millennia. And so they're much more natural and ambient than many other experiences you might see today. And that's proven out in the research as well. They're less disruptive to our daily life. It turns out that just having the presence of phone and other technology in the same space as other people disrupts the overall connectedness and how present we feel. In fact, a study from Harvard showed that just having a phone on the table disrupts your connectedness with both people by about 30–40% when you survey them afterwards. So technology has an inherently disruptive presence, and wearables, because they mimic classic form factors, are less disruptive in that regard. I don't think you can underestimate how important the human imagination is, right? We see countless examples. For example, this is an illustration from Jules Verne's From the Earth to the Moon. And it predicted space travel. Here we are in 2019 with a spaceship that's looking very, very familiar, right? Very similar. And so we can't understate that force and how much it plays into our daily lives. But that's only one part of it, right? The second part is hardware capabilities and the real investments and progression that's happened technically to enable wearables as a form factor. I don't know how many of you are familiar with Moore's Law, but I'm going to take a step back to Gordon E. Moore when he actually founded Intel in 1965. And at the time, he noticed a really interesting trend, right? He had these 4 data points on how chips and semiconductors were starting to be developed. And he theorized that, hey, every 2 years, the cost of this is going to decrease, and the amount of transistors we can put per square inch is going to double, right? Now, he made a very early call. There was only 5 data points when he published this paper in 1965. But as we know today, Moore's Law has held true. This is a larger graph showing all the major chipsets to have come out in the past 60, 70 years. This is a logarithmic scale, so it's a linear line, but it is going up exponentially. And I think what it really points out is that hardware has not slowed down. Chips have become more powerful, smaller, more efficient. I call that out because not so long ago, the head of Qualcomm in 2017 said that Moore's Law did not apply for wearables. He said that smartwatches had so much leftover capability to integrate that there was no opportunity to invest in more compute because you wanted to shrink the device down to make it thinner. You wanted to incorporate GPS tracking, heart rate, sensor variability, right? There were so many things to put in the smartwatch that Moore's Law did not effectively exist. However, we're in 2025 now. Moore's Law is starting to take effect because smartwatches finally have all the sensors you'd want to put inside of them. And that unlocks a whole new set of capabilities. For example, you could invest in a larger battery in the form factor. Garmin is famous for this. Their watches last for days, weeks, months even. And it's a very valuable experience to many users. You could also just make the device thinner. The Apple Watch Series 10 reduced the overall volume of their device by about 10%, which I know doesn't sound like a lot, but I promise that's actually an incredible feat of engineering. You could also unlock new form factors. There's a reason why we're seeing watches, or glasses, rings, pendants merge all of a sudden, and that's because the chips have finally gotten small enough to actually be inside of those form factors. Moore's Law is achieving the same amount of compute in a smaller size. But there's a fourth thing that could happen. You could just invest in more compute. You can make a more powerful device, and with that power, you unlock certain experiences and opportunities that wasn't available before. And we really don't see anyone playing in this space quite yet. And I think there's a huge opportunity there. So, we've talked about desire, we've talked about hardware. Let's talk about the user experience and what's happening on the software side. If you think about input, it turns out that the size of the device you're inputting on generally seems to scale with the precision and accuracy available, right? With a desktop, you have a full mouse and keyboard that's incredibly precise, and with a phone, you get touch screen, touchpad, some buttons. Turns out that's good enough. As we get to super small form factors like watches or other wearables, you don't even get touch anymore the same way. You have to use voice or you have to use gestures, because precision input on a keyboard just doesn't come across the same way. And it's that back end of the scale where you get too small to have precision input that limits the usefulness of wearables historically. And so the big evolution that's happened is that with the advent of language models and context, you can help obfuscate and bridge the gap that this limited input otherwise provides. And that's the big insight here, right? AI can be used flexibly as an input mechanism and kind of replace the shortcomings that a user interface otherwise has. So if you take an example, let's say your kid is sick and you need to reschedule all the meetings you have today. If you were to try doing that on a smartwatch today without LLMs, it'd be basically impossible, right? There's no way to navigate it effectively. You don't even know if some of these apps exist. You would probably spend more time than it's worth. You should just pull out your phone or a laptop. But with a language model, that command, my kid is sick, reschedule all my meetings, is possible, because it can use the context of understanding what it means to have your kid be sick. It can understand meetings. It can understand what it means to send an email to those attendees and explain. It can understand rescheduling and understand your schedule to make that rescheduling happen. And so that is a very powerful use case that's unlocked because you can use voice in a way that's precise now. And so it's really those three things. It's the desire and the will to build something in this space, the real hardware improvements to unlock, and also the user experience that enables that input with more precision and accuracy than ever before. So let's talk about the actual opportunity. How is wearables going to interact with our daily professional lives? We've had many ambitious visions of the future, what wearables will look like, how it's going to integrate, but I actually have some surprising news. Wearables have been part of our daily lives in professional workplaces, and we don't even realize it. Google Glass, famous dead wearable, is actually alive and well. It exists in warehouses. In fact, DHL just signed a 10-year contract with Google last year to continue their partnership using Google Glass in warehouse spaces. It turns out wearables have a huge value proposition for trade-based, highly physical, highly mobile jobs. And so let's get into that. There's two types of jobs here that I want to highlight, and we're going to get into the physical workspace there first. Wearables have certain qualities that trade-based jobs really excel at. They're good at quick tasks, things that take 30 seconds or less, so checking on an order status when you're on the warehouse floor. They're also great at things that are repetitive, things you have to do again and again and again that would suck to take your phone out, but if you have something already on you and ready to go, then it's not so painful. Something like verifying inventory numbers. It's also great for tasks that are unpredictable. You can't anticipate it happening necessarily, so you can't anticipate having the device on you. It just needs to be on you. Let's say there's like a hiccup in terms of the loading dock and you have to unload something. Lastly, and I think this one's really important, it caters to mobile and physical styles of work. Employees or workers or trades or craftsmen who need to be on their feet and move between locations. You can't have 85 computer terminals there to check in at all points. You need to have the computer on you. And that's a unique constraint that we don't think about a lot. In fact, I think wearables are actually great for almost all physical jobs and trade-based workers, but we haven't seen the integration yet. And I think it's worth asking why. Why haven't we seen this adoption? To me, the short answer is pretty simple. It comes down to money and economics at the end of the day. If you imagine a sliding scale that basically measures how much revenue per employee is generated, you can imagine two ends of the spectrum, right? You can imagine someone who might be working in a warehouse or an oil and a gas field or a moving company. And on the other spectrum, you might have someone who works at a fast food restaurant or does delivery. Now, both of these people would benefit a ton from having a wearable AI managing logistics, helping track orders, helping figure out what they need to do next. But there's a fixed cost to hardware and software that is right now pretty hard in terms of a limit. And that creates an invisible line on which one side of employees get access to really fantastic tools. And on the other side, you basically have the cost model fall apart. It's too expensive for some workers right now to integrate wearable AI, and that's why you see it in these very invisible sectors. Because it's people who are working ship docks, loading docks, warehouses, where we don't interact with them, but they're using wearable AI all the time. And it's the service workers where the cost basis isn't working out quite yet. But cost is variable, they'll go down. There will be a day where the cost basis of wearables decreases such that all physical and trade-based workers could benefit from wearable AI, and I think that's going to come sooner rather than later. So that's one half, but there's a second half here. What's the other story? The other set of workers that really benefit are client-facing high-knowledge workers, right? Lawyers, clinicians, sales reps, and we'll dive into that right now. If you could magically wave a wand and have an intern on you at all times to do tasks, what sort of things would you give it, right? Would you ask it to transcribe and summarize your meetings? Would you ask it to look up information from the last client meeting and get that ready for you? Would it just be a cognitive load offloading? You ask it to remember something and you trust that it's going to remember it for you. I have a beautiful intern I would love to introduce you all to, coming very soon, and it's wearables such as the Pixel Watch, which is what I work on. So it turns out these sorts of tasks that AI fundamentally excels at, capturing, distillation, recall, synthesis, right? These are all things that AI does quite well and defines a vast majority of client-facing jobs, right? But it's really effective in doing those when you otherwise want someone who wants to be a face and interpersonality between, right? You want something helping augment that person that's a frontline worker there. And you might be asking yourself, okay, this is great, but why isn't this just my phone doing this? They don't have the same limitations around mobility that you talked about earlier. And the truth is that the phone really is a jack of all trades, master of none device, right? The phone is not designed for certain use cases, so you don't make hyper-specialized hardware investments around microphone, battery life, reliability. You also struggle with interface and portability, right? The phone is not meant to be this. It doesn't have these external physical access points. So you have to menu, you have to open apps, you have to do things quickly, whereas with a hardware button, it can be a single invocation and then you're in the experience. Lastly, and this is important to call out, if you're client-facing, if you're user-facing, do you really want to have your phone out? We just talked about how disruptive smartphones and other technology is. In fact, I'm sure you've all experienced, if you work with clients, the importance of not having the tablet in front of you, right? Having the phone to the side. And so having a phone on the table in that meeting, I think is just super disruptive. It doesn't set the right impression. But a wearable can, because it matches kind of our expectations around what's appropriate in that session. And so we have our two big groups, right? We have high revenue physical trade-based workers, and we also have high knowledge client-facing workers. There's a beautiful group that's right in the middle, and that's doctors and nurses. This is probably the group that benefits single most from any of these wearable AI products that are coming out, and you're already starting to see the traction start to form. I'll pause a second so everyone can get their photo. And you already see the momentum happening, right? 31% of large hospital systems and practices have piloted or deployed an AI note-taking system, right? 31%. It's almost a third of all medical practices in the US. And it's only gaining momentum here, right? This is a study from 2025 as well. And so you see how much clarity there is and how much it's already clicking and resonating with users. So that's the business case. Now you're probably asking, okay, I love wearables, I love AI, I want to bring it to my business. How do I figure out the solution? And I've got a good framework for us to get in. Of course, every person's unique in terms of their challenges and what they need to build for, but I have this simple chart, right? I'm gonna call this the Mejia wearable BS evaluator patent pending, right? And we'll step through each of these with examples, but it basically goes through making sure they have the hardware fundamentals, making sure they have the right compliance standards, making sure that they have the feature set integrations you want, accuracy, precision, and performance, and lastly, cost, which I know might seem like the first thing you want to investigate, but I promise there's other things you want to verify first. There are 4 things that matter with devices more than anything: battery life, thermal performance, device stability, hardware reliability. If it's not achieving those 4, it's going to be a bad experience, and nothing you build on top of it matters. You may think that that's a logical conclusion, but people who were much wealthier and well-staffed than me have made this mistake. The Humane Pin, when it launched, famously had to be put in ice baths before doing press and tech demos because it would overheat constantly. And so you quickly see how losing these fundamentals means you've basically broken your product before you even get there. And you should do your work to make sure, hey, does it have a good battery life? Is it built well? Can I drop it? And it's not going to break when and shatter instantly if it hits the floor. Those are the sorts of questions you should be willing to ask a sales rep. The second thing is compliance, right? How is it treating the data, assuming that it's not 100% on device? In the US, the 2 big ones to think about is HIPAA and SOC2, but I'm probably sure you're familiar with that. If you're in the Europe, GDPR and the Cyber Resilience Act are the 2 big ones. These are pretty basic questions. Do they scream about it? Do they talk about it? Is it all over their website? Or are they antsy when you ask about it? Probably a pretty good indication of their tech stack. Next, you want to make sure that you actually have the integrations and platform business administrative tools that you're going to need to really have a successful product, right? Do they provide APIs that allow data to leave their ecosystem and enter your platforms that you're currently using, right? Do they have administration tools that allow you to manage users, members, track usage? Can managers see anonymized but macro insights about how the team is performing, synthesis of data, right? Taking it beyond the individual consumer into an actual platform team use tool, right? That's important, and many companies today are still fundamentally building things for an individual consumer. You want to be pushy on that, and you want to understand their roadmap. There's also a lot around performance and metrics you want to measure as well, right? We'll take an example of voice as a good example, because I think voice is a pretty core modality. I also apologize, I know this is a bit of an eyesight chart, but I'll explain it. Word error rate is basically how, for every 100 words, how often does it transcribe one of the words as wrong, right? If it's less than 5%, it's industry leading. If it's above 20%, it's basically useless, right? And there's something in between there as well. How do they measure their summarization accuracy, right? Can they talk about the metrics, the benchmarks, the ways in which they're measuring? That's important. And you also want to measure hallucination rate, right? How often does it make things up and get things wrong? 0 is basically impossible. Don't have that expectation. But for the fields like legal and medical, where there's really momentous decisions, you want to aim for that 1 to 3%. Business applications that are sensitive, below 5%. Anything above 5%, I would say, is really better for creative and personal use. You can't rely on it to make a reliable business decision. Lastly, let's talk about cost, which is really important as well. We're going to take AI note takers as an example. You might have heard of like the Plod note or the Limitless pin. They charge you for the words transcribed, not the minutes transcribed, not the minutes recorded. And so you want to make sure, hey, is this thing going to automatically transcribe every single word I record, or am I going to need to opt into it as a user? If you're doing a pilot, you really want to make sure that you're aiming for something where you pre-negotiate the cost or try to get some unlimited plan, because they can quickly add up if you're not prepared for the use case in that pilot. Paying for storage is somewhat uncommon, not really well done, but might happen. And then almost all companies will charge for the devices in addition to the service as well. So that's pretty standard, all things considered. Lastly, I want to talk a little bit about what it's like to actually build wearable AI, right? So this is maybe more for the technical nerds in the audience among us, but I'm hoping there's some out here. I also just want to geek out for 5 minutes, so please indulge me. There's 3 big things I want to talk about. When you should bring wearable AI onto the device versus off the device, techniques for on-device optimization and AI development, and then 3, the future of hardware that I'm really excited about. Over the past 2 years, the cost of inference has decreased 99.7%. If you take the least expensive model 2 years ago and compare it to now, it's just getting cheaper and cheaper. So cloud is somewhat of an inevitability, right? It's just so cheap. And so you really have to ask yourself, why would I bring something on device? There's 3 big reasons that I'd like you to think about. First of which is availability. Doesn't need to be on device from an availability and security perspective. So, if you're building something that needs to be available 100% of the time, you can't rely on cloud, right? Pretty intuitive. There's also a latency story here. So particularly with glasses or augmented reality devices, you need to be faster than real time. Cloud latency is about 100 milliseconds, give or take, so most applications can probably withstand cloud latency normally, but there's certain limited applications that can't. The last one's privacy, and this one's really interesting. As an example, on the Pixel Watch we just built, and we're going to be shipping a generative texting experience, and that's 100% on device. And that's because many messaging platforms, such as Android Message or WhatsApp, requires 100% of device processing be done on the device. You can't send anything to the cloud. And so in those sorts of cases with communication, you actually need to bring everything on device because it's a policy standard. And there's many cases of these that are available as well. It's also worth noting that we're not building devices to be standalone, but really be a team that triages together, right? The watch in this case is less of a standalone device and more of an interface into the experiences that you might be trying to build and experience as well. And I think that's the big idea that I really want to hit here, right? On-device is not there to create independently capable AI wearables. It's all about creating wearables that exist as a hybrid ecosystem. They set a new baseline for what you can expect from an experience, and everything will be that good, if not better. And that's the important framework there. You're building user trust. There's a few techniques to talk about when it comes to wearables and some spaces here as well. I'm going to briefly jump through these because I think if you're technical, you might have encountered these before. The first of which is fine-tuning. So traditionally, with a lot of model development, you might try to do something like, that laser pointer doesn't show up. You might try to fine-tune just a small part of the model, and then otherwise the feature model largely stays preserved. It turns out for small form factors, you don't want to fine-tune with an adapter. You want to fine-tune directly. You end up getting 20 to 30x the performance if you fine-tune directly on a model. It limits your flexibility, but improves overall performance quite well. Quantization is another big one. Basically, quantization is taking out significant numbers and making them less exciting. So let's say that you have 2 big numbers and you're multiplying them. Realistically, there's a huge chunk of these numbers that don't matter. The purple isn't showing, but basically imagine that last half gets chopped off. If you chop it off, turns out you basically get the same number at the end of the day, and that's quantization. If you take operations that happen in 32-bit and you transform it to 16-bit or 8-bit or 4-bit, you actually pretty much get the same output, and you end up saving 4x, 8x the memory that you would otherwise have to spend. Super powerful technique, works really well on a small model because you're not doing many operations. Memory carve-outs are another big one, but I'll briefly skip over them. The last one I want to talk about is pruning. The idea is you just selectively remove a node from the LLM, and you're able to improve performance pretty dramatically. I know it sounds crazy that you can just remove part of a language model and it'll perform just as good, but they're largely alchemy, right? We don't really understand what's happening under the hood there. Lastly, there's a few hardware trends that I don't have a lot of time to talk about. Unfortunately, we're just at time. The biggest one that I want you to all think about is this idea of an NPU. So you've all heard of the CPU, and NVIDIA is really good at the GPU, but there's going to be a new generation of chips called an NPU, a neural processing unit. And that's like a GPU on steroids. It's built to do AI tasks. I would not be surprised if many of the consumer devices we buy and use every day are going to quickly start showing NPUs. So that's all the time I have, unfortunately. If you have any questions, I'm more than happy to answer them on the side. They're going to kick me out. But I would love to connect. There's my LinkedIn. The QR code's also my LinkedIn. I'll be posting these slides online. Thank you so much.